I've changing the slides actually.
Okay.
All the slides I'm just moving one by one so that the motion is there or not. I just wanted to know this.
Motion is not there, ma'am. Can you please put it in full screen mode?
Okay, when I put it in full screen mode, I'm not able to get the
Okay.
Okay, this is full screen mode.
Okay.
It's not changing, isn't it? The slides are not changing.
No, ma'am. This is propagation.
Okay, I'll do one thing then.
Now it's changing, ma'am. Like you can put it like that also, ma'am. Visible.
So, good evening to everyone present.
Good evening, ma'am.
In this Google Meet to attend this presentation. So let me start now. So the entire world has actually witnessed the growth of wireless communication networks. So how explosive the growth was. And the growth was tremendous after 2000. And it has surpassed the wired subscriber rate as well. Now, most of the countries have deployed 5G, and we are actually trying to switch over from 5G to 6G. Though not completely, 5G has been deployed and the benefits have not been enjoyed by most of the users. The researchers have started, the academicians and the researchers have started to look in for what something new they can expect from 6G standards. This is what is the current scenario. And my topic will be restricted to machine learning in 5G and 6G. How we are going to apply or how this machine learning aids in improvising the network performance of both 5G as well as 6G. So this is going to be covered. So the agenda of my presentation is covered under 2 modules. In the first module, I would be telling you about what are the key differences between 5G and 6G, and introduction to ML concepts, artificial intelligence concepts, different types of learning approaches which are available, because these things are essential for you to understand next module. So the first module will be completely about the prerequisites. Then we will move on to module 2, where why actually we go for AI and ML for 5G and 6G. And what are the possible solutions? What are the challenges? Both implementation challenges and the solutions will be discussed. And finally, I'll conclude the session. So this is my plan. So we'll first start with the projections on 5G. Plus slide, you must be very much familiar. So I'm not going to spend too much of time on 5G and 6G slides. I'll quickly move because already we are running short of time. So as all of you know, we started with 1G in 1980s and now we are in 5G. So the curve moves like this. We started with analog, which was only for a voice service, typical voice calling. Then we moved on to 2G with SMS with a data rate of less than 64 kbps. And what was practically available was only 10 kbps. That was the data rate. Then we moved on to 3G communication, where we expected some 10 times more than what was offered in 2G. So we started enjoying services in the data rate of 100 kilobits per second. And the access technology also started to improvise. We have started to move to CDMA approaches. And then we moved on to OFDM in 4G, where we expected at least 1 gigabits per second. And now we are in 5G. And if you look at this 5G structure, you can see that MIMO has come into the picture, and we have gone to millimeter wave communication, and the networking has become a software-defined thing, and OFDM is also playing a vital role here. And we expect at least 10 times more than what was offered by 4G, and 10x times to 100x times more in case of 6G. So you can see that the concept of Internet of Things started In 4G LTE advanced, in the later stage, 4G plus only, we started having this, realized that IoT can also be embedded with 4G. But the full benefits, potential benefits of having IoT driven wireless system was realized only in 5G. And we expect a massive connectivity in 6G. And look at the 5G scenario. All of us know this. If you take this scenario, you can see there is a E node B here, which is in the macro cell, and you have a lot of small cells present here. Basically, all the small cells are introduced to improve the capacity. If you carefully observe the evolution of wireless system, starting from 1G to 6G, there is a continuous hunt for bandwidth intensive applications, upsurge of data rates, higher data rates or high throughputs, quality, and unimaginable services have started to roll in, starting from 1G to 6G. So these are the user-driven factors which have pushed the wireless standards from 2G onwards till this particular point of time. And we can see that in 5G, we use millimeter wave communication and small cell sizes. A lot of advanced networking architecture is being used. Okay, I will show you when I get into the concept. Then all these are basically to improvise the reliability of the communication setup. Any communication
Ma'am, your voice is not audible. Please unmute you from your side. Hello, ma'am. Ma'am, your voice is not audible. Hello, ma'am. Hello there. Any participant? Are you able to listen to me?
Wait, not audible,
Yeah,
sir.
it is audible, sir.
My voice is
I think you
audible,
can
na?
call directly
Yeah,
the
your voice.
expert. That is better.
Okay. Okay. हाँ, हाँ, Okay, sir. Just within 5 minutes will come. Dear participant, ma'am is a little bit busy. She will just come back.
Okay, sir. Fine. Thank you, sir.
మనం చూడలేదు పోతున్నారు.
Hello.
Hello?
Dear participants, can
Yes, ma'am.
sorry.
Ma'am, your voice is not clear. Hello?
Let me share my presentation again.
Ma'am.
I'm not allowed to share my screen. But I'm getting response here.
Madam,
Uh,
voice is getting break, madam.
I'm not allowed to share, madam. There's some issue. Okay. I'll go
You already
and
shared
join
that.
back. Okay, when I'm about, you're not allowed to share your screen. I'm not even able to share. Something is is done it. Am I audible, ma'am? Scott?
Madam, no, madam. No, madam. Some disturbance is there, madam. Not clear.
Okay, I'll just join once again back. Just a minute.
Yes, madam.
JD ma'am, good evening. One suggestion, ma'am, whether you're using two systems or whether you're using single system, ma'am.
I'm using only one system. Sir.
Dear participant, please mute your mic, madam. Mic, sir. Dear participant, please mute your mic.
I'll do one thing. I'll stop present.
And now your
and
voice
then
is clear,
I'll join.
ma'am. Your voice is clear now.
Okay.
You
Now
can
your
start
voice is
speaking.
clear, ma'am.
Okay. Someone wants to join the call, ma'am. Please submit them.
We are doing that, ma'am.
Resume your presentation. Yes. Yes, fine.
Ma'am.
Yes. Hello, Anup sir.
Ma'am.
Yeah, what happened?
I don't know, ma'am. Maybe some technical problems are there, ma'am. It will just come back.
Swapna, madam. Swapna, madam.
Madam.
Madam, already PPT send
Came,
చేశారా?
ma'am. Madam came. Link I have sent, madam.
No, PPTs.
PPTs.
చెప్పండి madam.
Yes, ma'am.
ఉందా మనం మెయిల్?
ఉంది మేడం. మేడం మ్యూట్ లో ఉన్నారు మేడం.
I'm sharing now, ma'am.
Yes, ma'am.
Okay, okay.
ఓకే.
Sorry.
Okay, no problem, madam. It's okay.
Now, can you see the slide?
Yes, ma'am.
Is it
Yes,
Yes,
ma'am.
ma'am.
visible?
ఎస్ మేడం.
Yeah, it's visible.
Yeah, it's visible. So, what is the title of the slide?
Yes,
Is
ma'am.
it Rise of 6G? Okay, thank you.
Rise of 6G.
Okay, so I was just trying to tell you about what exactly is 6G and how it differs from 5G. So, like 6G is not totally different from 5G, as it's very much essential that there should be a backward compatibility. The foundation for 6G is actually laid by 5G only. And the boundaries which it has not touched upon, which the 5G has not touched upon, actually been touched by 6G. Like how okay, sorry. So fine. So what was not being met out by 5G, we are trying to give some technological aid so that 6G can meet out the desired requirements. Not only the requirements of 5G, far beyond that. For example, the data rate should be 10 or 100x times more than that. The connectivity should be 100x times more than that. For example, 1 million devices in 1 kilometer, 1 square area kilometer. This will be 100 million devices. So you can imagine 100 times more data is going to come from 6G. So 6G can definitely make use of artificial intelligence because AI always looks for or demands for, it hunts for a lot of data. So that big data can be provided by 6G. So this is a very, very firm belief people have on it, and therefore 6 available, it's going to be like how to meet out the requirements of 6G. There are a lot of enablers, technological enablers for 6G. Like I have just listed a few of them, starting from terahertz frequencies. So from millimeter wave, now we are going to switch over to terahertz frequencies. And we are going to completely integrate artificial intelligence. This is one of the major highlights here, which we expect. So 6G cannot work without AI. So it is going to be integrated. So the word is very properly coined here. And apart from that, we have the holographic communication, where you get the picture is going to be a 3D picture. So that is the kind of image that you're going to experience. And apart from all those things, there is a careful need for enhanced security and privacy. This is another thing which are the futuristic vision of what 6G is going, which is the deep learning. So what exactly is the difference and where we apply each one of it? I'm just giving you that bits. So it is possible through AI, it is possible to realize a machine called as a smart machine. That means we can make a machine to think and carry out decisions on its own. It can perform a task similar to how a human can perform. Now, how these machines get that smartness? What they do is they learn from the experience, from the past inputs. They remember the past inputs and try to understand the pattern which is present in that. From that, they gather the experience. And after that, at a later point of time, when a new unknown input is given, it will try to map that to what will be the possible output. So it will adapt, it will adjust to the new input, and it will be able to take a decision on its own, like how a human can do. This is what exactly is AI. So how do we realize this? AI is basically realized with the help of some algorithms, some intelligent algorithms. So how this concept of intelligent algorithms have started? Now, we all started using computers. So when computers were introduced, initially it was used for the ticket reservation systems and those things. At that point of time, we were using what is called as rule-based concepts. So if a particular condition is met out, okay, if that is true, then it has to do this particular function. Like that, some rules were defined and given to the black box model, and the algorithm will first check whether those rules are satisfied. If it is satisfied, it will go to a particular statement for executing a particular operation. Otherwise, it will not do it. So this is how it started doing it. Then later, from that point, we started getting into something called as expert systems. It is a bigger level where too many complicated rules will be there. Lots of ifs and then conditions will be there, and the modules will be present in different parts of your memory, and everything will be collaboratively considered, and based on that it will take a smart decision. Then we started using neural networks, which is basically like how our brain works. It's going to mimic exactly how a human brain thinks and make the decisions. So all these things will be possible with the computers. So this is just like how we have seen the generation of from 1G to 6G. Here, from 1950s onwards, we started thinking about or started using about AI. Look, only in this particular stage, people have understood that machines can be made to think. They really were involved in the thinking process, and we are using some statistical algorithms, which is called as machine learning approach. It became popular only in this particular period. After that, after 2010, deep learning have become very famous, and because it has got a lot more capabilities beyond what machine learning algorithms could do, because this was able to learn on its own. And now currently generative AI, which everybody is using, starting from typing a message till whatever we say, we order some food in Swiggy and it remembers and it gives us, this is all your favorite dishes, you want to take up, everything is the concept of generative AI. And we get all these advantages with AI. It adds intelligence, it adapts, it analyzes the data deeper, and will be able to provide incredible accuracy. That is a concept that people are talking about. And we get most of the data. AI can do a lot of analytics with the data what it has collected. So machine learning is obviously a subset of AI, and it is going to focus on the idea. What is the idea? It learns from the data. Here is a problem where what I was telling. So only you can apply this machine learning, deep learning concepts from or into a system where a lot of data is available. Availability of the data is the biggest challenge, and that we were able to get when we started introducing industrial IoT, okay, into 5G, 160 and other things. Okay, so with this, with the data, they identify the patterns, they make decisions on their own. Okay. So there are three different learning models, which are available, starting from supervisory. Next one is unsupervisory model, and the third one is the reinforcement model. So if you take the supervisory model, it is like this. You have a complete set of data which is available, and there is a supervisor who does the labeling of the data. If this is the input, this should be the output. Like that, some kind of instruction will be given by a third party, and therefore we call this a supervisory learning model. So the algorithm will not work on its own. Some additional input in the form of labels will be given, and that will be processed, and this mixed data will be segregated, and you can see it is properly classified. Basically, all machine learning models were very good in classification approaches, okay, for those kind of decisions. Then we have unsupervisory type, where this kind of supervision is not being done, and the algorithm will start doing a grouping. So this one has one particular input is given, it has got a particular attribute, it will put in one space. The next input will be fed, it will check whether the same characteristics of this one is there in the new input. If it is there, it will group it here. Otherwise, it will put it in a different group. Like that, it starts clustering. It groups and put them, so that all the members in this particular group will have certain unique features in them. And if the difference between them is vast, then it will put it in a different group. This is the unsupervisory model. And the third one is a reinforcement type, and we expect this reinforcement type to play a very, very important role as far as 6G is concerned. Now, how this reinforcement type works is basically the raw data is not initially in both the cases. In the previous cases, we do some training, and then we are making the model to understand the patterns, and after that, when a new data is given for testing, it will be able to correctly make a decision or the prediction thing. But here, on the go, the decisions will be taken. So when an input data is given, there is an agent that we call that as an ML agent. This ML agent will choose a particular algorithm suitable for handling this data. Based on that, an action or a decision will be taken by the agent, and that action will be fed to the environment. Environment is, say, for example, it's a 6G network. Some resource have to be allocated. So this resource can be allotted to that particular device. Like that, some instruction will be given to the environment, and the resource network manager will be doing that allocation. Let us assume like that. After the allocation, whether the quality of service, whether the reliability, latency, everything is being satisfied or not, based on that, a reward will be given. If the action taken by the agent is not suitable for the environment, instead of a reward, a penalty will be given to the agent. In this way, the agent will be understanding for every input whether it gets a reward or whether it gets a penalty. Based on this, over a period of time, it is going to accumulate all these things and gain a lot of intelligence. Once it gains intelligence with a lot of training samples, after that, on the go, it can make the decisions on its own. So this is how reinforcement type of data is going to work. And we have different parallel processing approaches here. These are the different sensors which are providing the data. The data is shown here. You can see different colors indicates different attributes of the data, and all these things are fed to the input layers. And from the input layer, we have a lot of neurons. And after the input layer, you have, depending upon the number of variables, input variables, you have some 10 input variables, you are expected to have some 10 variables here. Then from there, the data is going to get processed through all the intermediate layers. We call them as hidden layers. And if the number of hidden layers are going to be more in number, we call this model as a deep learning model. Otherwise, it's going to be a simple machine learning model. Now, any one of the neuron will get activated, and accordingly, a 1 or a 0 will be fed to the next stage. Like that, the input is going to be processed by every layer and by every neuron present in each of the layer based on the activation function, and it is going to reach the output layer. At the output layer, what happens is the classification is going to happen. So you can see here all the cross belong to a group, and all the zeros in a different color, mustard color is a different group. Like that, the classification is going to be done by the system. Now, what it does is, every time it does it, it is doing some prediction. It will just compare with, or it validates with the original value. If it is matching, then it is fine. Otherwise, an error will propagate back, and all the weights of the neuron will keep changing until what it predicts and what is there in reality matches exactly. That is, the error should be brought close to zero. So this phase is what is called as training phase. So we train the network to perform a particular task. Once it is properly trained, any new data that is given, it will be able to process it and give a perfect decision. So that is what is shown here. Sometimes it may make an error also, like there can be an overfitting or an underfitting. So these two cases will happen when very less amount of data samples are available, or if the network is not properly trained with good samples, then we land up with these two problems. And if it is with optimal number of samples, then we get a good result, desired result. So I've already told what deep learning is. Basically, it's a subset of ML where huge amount of data is used for training it. And here what we do is no supervision, unsupervision, nothing of that sort. So here, the supervisory role is to extract some labels, some features, and give it to the input. No? So that role is done automatically by the network itself. So human intervention is totally zero here. That is why we call this as deep learning. So both feature extraction and classification will be performed by one single network. And you can see, of course, more number of intermediate hidden layers will be present. So it is more complex, and the computational power that is required will be more. And that's the reason why there are certain cases where we need not go for deep learning. We can even accomplish the task with machine learning. So we need to understand what is the criticality of the application, and depending upon what is the size of the data that is available, and what is the kind of the output decision that it has to take. And if it is a unfuzzy type of output, then we can use a simple machine learning approach itself. But if you have a fussified, which means the output cannot be clearly taken, the decision cannot be clearly, sometimes we also land up sometimes with this kind of whether I have to take this decision or not. So we have a fuzziness in our decision-making process. For such things, we can go for applying deep learning. So something which is very crystal clear, we can go for machine learning, because that will consume less amount of power. So power becomes very important, because in 5G networks as well as in 6G networks, we are focusing in reducing the consumption of the power. Thereby, we make the system more energy efficient. So these are the aspects which I wanted to tell you. And there is one interesting and a very advanced type of learning concept, which is called as federated learning. So what is this federated learning? Instead of having the entire intelligence situated or housed in one particular controller or a device, what we do is, it is not in the entire network. So we are distributing it. Instead of a centralized behavior, we are distributing it to different end devices. When we distribute it, we are not distributing the data. You can see that a network is created by this, and that network is sent to all the end devices. So we call this as federated learning, because it's a collaborative learning. With the data, what this one is producing, it is going to train this. So that knowledge now gets transferred to this. So because it will take too much of time to make one system, centralized system, to get trained up. It takes too much time. So what we do is, the knowledge gained by individual end parties completely is transferred to one centralized unit, so that within a very short span of time, it is able to achieve. This we call as transfer learning approach also. So these are the ways by which we are planning to implement our 6G basically. Moving to the second module. So first module, we were focusing completely on the basics of 5G, 6G, and the differences and what AI is ML is different types of learning approaches and other things. So this module is, let us think for why ML and AI is needed for 5G and 6G. So if you look at the expectations of 5G and 6G, whatever we have seen in module 1, I have just listed that as points here. So there is a huge demand for high data rates. So there is a surge in the, that's why I've used the word upsurge in data rates. Connectivity is massive connectivity, and we want the energy consumption to be as low as possible for the connected devices, because remember, the connected devices are going to be small, tiny sensors. They have a lot of constraints in the storage, in the computational levels, the power level, okay, all those things. So that's why we have to go for energy efficient process here. Then ultra low latency, because we also want latency to be less than 1 millisecond for 6G or less than 10 milliseconds for 5G. And reliability should be very, very high. It should be very high, of the order of 10 power 5 to 10 power -9. And QAE is quality of experience also should be good. So reliability is from the network perspective. From the user perspective, the user has to be convinced. Whenever if I am involved in a immersive application like a virtual reality, I should really get the feel that I'm doing that. For example, it's a gaming application. So I should really feel that I'm a part of the game and get that experience. So that is also very important here. And apart from that, as more data is coming into the picture, immediately we have to bring in the concept of privacy and security. That also is needed. So how do I achieve all these in one go? Yes, it is possible with our artificial intelligence combined with AI, ML, and with DL. So what are the possible solutions? We have so many solutions available, but the best solution which can meet out to most of the requirements which I have told you in the previous slide is Edge AI. Edge AI is, in the edge device, we try to impart the intelligence, and they also become more intelligent nodes or smart nodes. Instead of embedding all the intelligence in one centralized networking infrastructure, you distribute it among the different nodes. That is the main concept of Edge AI. And there is a lot of challenges in this Edge AI also, because we try to introduce some intelligent models. We need to see to what is the capability of the device, and accordingly the computational approach, the power what they consume, everything has to be reduced. So the algorithm needs to be sliced down to that particular level what is expected for a edge device. So accordingly we need to work on it. So though I'm telling this as a solution, there are a lot of research challenges behind this. And if you leverage ML in wireless system design, most of the modules of wireless system design, if you're bringing in ML, tremendously your task of improvising your network performance will improve. It will not be a marginal improvement, it will be a tremendous improvement. That's what I want to tell. So we need to embed this machine learning algorithms into radio resource management, mobility management algorithms. All these will help in meeting out our requirements. And why only to restrict it to only these algorithms? All of us know that all the systems will have a layered architecture. We are all familiar about the OSI layered architecture, 7-layered architecture. So here, in all the layers, we can embed the intelligence. We can make them much more smarter. So that is a concept. So if you bring it, and cross smartness also can be brought in. Collaboratively, both the layers can introduce their intelligence, and they can work in a connected fashion so that we achieve a concept called as connected intelligence. That is also possible. So all the possibilities with AI and in 5G has been listed over here. So if you look at the first solution, what we are trying to do here is we are enabling the nodes, end nodes, network nodes, in the sense these are the user devices. So the user devices have to be made smarter by making decisions on their own. Instead of waiting for the network to always give command, they have to take individual decisions on their own, so that you can avoid lot of time. Okay, so low latency, you can achieve this ultra low latency, enhanced privacy. Why privacy I'm telling here is because end nodes, when you are operating at the end nodes itself, the sensitive information need not go to a centralized place where it is processed and the response is given back. It is the data is present in a place, and there itself you do the processing, and there you take the decision. So the security breach process will not come into the picture. So you have very good, excellent privacy aspect. Security and privacy will be preserved here. And not only that, energy bandwidth efficiency. Why I say this is because something has to be sent from the end node to the E node B to the base station. Some resource have to be allocated. So those extra control channels, what are being assigned for this exchange of data or for the control information, can be completely avoided. So bandwidth efficiency and power invested also can be avoided. So all these benefits, and moreover, in what context it is, whether it is for a telesurgery applications, whether it is for a smart transportation purpose, depending upon that, the device will know its own preferences, and accordingly, its capabilities can be improved. So, and scalability also, because we are deploying it in a particular node. If you have some 1,000 nodes in a particular network, even if the number of nodes is going to grow, the same thing is going to be duplicated. So scalability also will not be a problem. So Edge AI is definitely going to be a very, very important pivotal process, which is going to be embedded in all the 6G devices. And then if you go for embedding ML in wireless system design, you can think of why the channel modeling can be done. Can this be made with the help of ML? Can the channel estimation be made with ML? All those things, even transceiver design. See, for example, what should be the modulation that has to be chosen at this point of time when the channel condition is preserving. If your SINR value is very poor, then you have to go for a BPSK modulation scheme, and you have to go for a higher order coding approach. So these adaptive decisions can be taken up quickly with the help of ML. Just you need to do the training alone. After that, it can take care. So when you do all this, you are actually trying to convert your network into a self-healing network, or you can also call that as self-managed network or a self-organized network. So when you try to do this, if there is a flaw in any of the routing nodes, then it can take a alternative path. It can do everything on its own, take a decision on its own, when the smartness is brought into even to the micro level of the devices or the nodes which are present in the network. So thereby your QoS and quality of service and quality of experience both can be improvised. Then we can go for, and mainly if you look at the papers, starting from 2018 onwards, most of the paper, nearly 40% of the total papers which are published in most of the communication letters, starting from the reputed publishers of IEEE till the last point. Till that point, if you see, there is a statistics given, which is around 40% of the papers were completely on how to apply artificial intelligence or machine learning in resource management. So they were completely focusing on this. That's why I thought I should put a separate slide for this. So here, the algorithms are basically centralized algorithms. Till 4G, we were using centralized. And 5G also, it was just an extension of 4G with small modifications. So initially, when they tried with the first version of 5G, it was centralized. And the algorithms were based on heuristic approach. And it was little complicated. Too much of information has to be gathered before taking a decision. So this was unduly introducing a lot of delay, and the performance in terms of throughput was suppressed greatly. So these are the problems people were facing. Therefore, they cannot meet the performance requirements which was promised for 5G networks. That is the reason why 5G standards were not being actually met by most of the network operators. So what is the reason? If you look at examine the reasons, we can see that the mobility management has become very complex because the cell size has started to shrink, more handoffs, okay, and how to manage handoffs within a delay, proper resource have to be reserved. When you reserve more resources only for handoff, how will you manage the incoming new calls and other things? So this is a problematic thing. Then we can, the next thing is the infrastructure, network infrastructure as such is very complex. You don't have a very simple or a streamlined setup. It is very highly complicated because the access comes from different points, and the decision-making process is also obviously lengthier. When your network infrastructure is higher, it's very complex, obviously the decision process also will be lengthier, and therefore it's very difficult for the existing resource management algorithms to work effectively in a dynamic environment. Therefore, we have to go for what is called as automation. This automation can be achieved with the help of ML algorithms and AI algorithms. Now, though there are different layered architectures which are available here in this particular diagram, what I'm trying to say is you can group all the 7 layers. We have 7-layered model, also we have 5-layered model. So you can group them and as 3 layers here as physical layers, and all the other layers are brought under middle layer, and the last layer is the application layer, which is referred here as the end user layer. If you're going to embed this ML and AI here in all the layers, you will be able to achieve excellent performance. So if you look at the physical layer, you can see that there are a lot of wireless sensors and RFID systems. All these hardware devices, okay, they have something called a sensing layer, and they collect the data. This is the functionality of them, and the physical layer collects all those things, and with that it performs channel coding, decoding, estimation, all those things. Then it goes to the next layer. Like that, it is going to progress and finally reach the place of application layer, where feature extraction is being done with the help of ML. Feature extraction is the desired inputs or the input variables which are to be used for training the network. So those things are extracted by ML, and then they are fed to the network. So after that, effectively, the system can function properly. So in all the layers also you can bring it, and you can have a crisscross arrangement also. That is also possible. We talk about cross-layered architecture, where the input from one layer can also be, the intelligence obtained here can also be used in the next layer. That is also possible. So with all this combinations of permutations, the system becomes highly intelligent and highly smart, taking wonderful decisions. So this slide is basically like here we have something called as channel estimation. I just thought, can I give a small example with the 2 slides to show you how the channel estimation can be done with the help of ML. So if you apply ML in physical layer, particularly for channel estimation, then how ML is actually helping you? What are the advantages? Let's take a scenario, conventionally how the approach is going to be there. I've taken a very simple networking architecture because it's a scenario. We can have a macro cell. This blue one is a macro cell, and all these white ones are the dense small cells. And the small cells, we have this tiny base stations with reflecting surfaces here, intelligent reflecting surfaces up there. And in 5G, we have a concept called as cooperative communications, where the transmitter and the receiver will not only be involved in the link, there can also be a third party or the intermediate nodes. You can see that this base station is assigning a beam here, and this is beam forming action. And you can have an intermediate node which is not being shown here, and the color of the beam alone has changed to yellow color. So there is an intermediate a cooperative node here which receives, and then it is actually passing the information back to this particular node. Like that you have for all the cases. This is basically done for giving an extended coverage to all the users. So this is one of the important feature of 5G. So this is how the setup is. Now the actual scenario is, you can see this is, we are taking an objective of how to characterize the model and estimate the wireless channel for a MA-MIMO. MIMO, all of us know, multiple input, multiple output. MA is massive MIMO, and millimeter wave, because we are using millimeter wave frequencies. So you can imagine a scenario like this, where you have more than 1,000 antennas present here as an array. And they all communicate, all these devices, some 6 devices I've shown here. one on the left hand side, other one on the right hand side, and there is a beam forming which is happening. Okay, this one wants to communicate with this. So there is a, you can see that there is a beam here, and from here it is processed and sent to the other one. Something like this. This is the actual scenario, how the estimation process becomes very complex when because you have more number of channel coefficient. So your channel matrix size will be of the order of m comma m, m cross m, where your m is going to be more than 1000 or something, because it's a massive MIMO. So the number is going to be a very big number. So the size of the matrix is unimaginable. So this problem can be easily tackled with machine learning. So let us assume that you have a machine learning model. The input is the training data set, and the output will be O. So you are going to, H matrix is your channel matrix. When you assign this matrix, you are training the data and training the network with that particular data, and you're going to get expect the output, which is HI cap. So it is indicating that it is a predicted output. So the training is going to happen like this. All your channel coefficients will be trained by the network, and the expected output is validated every time. And if it is deviating more from the actual value, then the weights of these networks will be adjusted until the device or the learning model is giving the optimal output. So when you do this, once you do this training and you finish it off, we get a lot of advantages. What is the advantage? When I do channel estimation, physically what is being done, every time the SINR value has to be sent from the receiver to the transmitter, so that the transmitter understands what is the channel condition that is existing between the transmitter and the receiver. So you are actually using some control channels. So the pilot feedback signals, whatever are being sent, can be avoided if you're going for this learning model. So when you use this learning model at the base station, you can reduce the feedback, unnecessary feedback from the mobile station to the base station, or from the, it is vice versa, from the base station to the mobile station, depending upon which is a transmitter and which is a receiver. So bandwidth can be reduced. You can save a lot of control channels. Number of control channels can be reduced, and the hardware also gets reduced at the base station. So these three attractive benefits you get when you are going to embed your ML here in the channel estimation process. So the next part of your module 2 is AI-driven solutions for 5G and 6G. So I'll just take some 20 minutes time, not even 20, I think 15 minutes time to finish it off. I know I'm running short of time. So we have clearly understood that if we integrate ML into network infrastructure, let it be a 5G or a 6G network infrastructure, anywhere if you integrate, we get multiple benefits. Let's see what all benefits we get out of this. So it's possible for us to manage the dynamic traffic. So this is an important setfall in the current 5G systems, where dynamic traffic management could not be done by the conventional systems, conventional 5G systems. Until and otherwise it is embedded with 5G, this cannot be handled. Why? Because the 5G systems, when they are using the leverage of ML, they can predict the traffic patterns. Well in advance, if you are able to predict the traffic patterns, then allocation of the resources can be easily used. Which cell requires more resources, which do not require resources. All this planning can be done. And when you do this planning, automatically traffic congestion can be avoided, and the transmission of the data can be very smoothly done, even during peak hours. So non-availability of the network resource will not be a problem if you are going to introduce ML into the 5G or the 6G network. Not only for the traffic management, even for beam forming and beam management, we can use this. So all of us know that beam forming is it's a technique for enhancing the signal quality. And not only quality, extension, range also. Range extension is possible with beam forming. And you can optimally use your beam forming capability with your ML. That is one of the interesting aspects. Thereby, the signal strength can be improvised. And the main reason for why we go for highly pointed beams are because we have to avoid the unnecessary interference from the neighboring units. So those things also can be avoided. Not only that, we can use this for saving the energy. So energy consumption can be reduced drastically. How? Because once you could predict when the traffic is going to be present more and when it is not going to be present, when it is going to be moderate, when it is not totally absent, when this kind of prediction is done, then accordingly you can make the device to go to the sleep mode when totally the network is not there, or it can be brought in other modes. So you can operate it at different levels. And not only this, you can balance the load by sharing the traffic. That is also possible. So in this way, we can efficiently manage the energy. Interference management, as I've already told, with ML, it is possible to predict what is the source of interference. See, when we want to mitigate interference, it's very much essential that we correctly point out the source of interference. That is possible with ML. That's one of the very interesting advantage that we get with ML. And obviously, when you're able to have a good control over your interference, when you're having control over good dynamic traffic management and energy consumption is brought down, with all these things, QoS enhancement is also literally possible. So I have told you what are all the features, the enablers. Which is the enabler for 5G and 6G is our machine learning. So yes, with that, it is possible to achieve definitely a very good performance improvement in network. For sure, that is going to happen. Is there any challenge in implementing this ML in 5G and 6G? That is also another genre in which we have to think of. So that is the reason why I thought I should put this slide. So implementation challenge of ML in 5G. So it's not for 6G here because we have not actually tasted the services of 6G. So we are still in this 5G aspect only. So what possible problems will arise? First thing is we need to have a good amount of high quality data. So not only high quality accurate data, it should also be a huge amount of data or vast data that is needed. Hello? Hello? Okay. I thought someone is asking a question. Okay. So this is one aspect. So how do I get the training data? Can the existing network be able to provide me this data to train the model? Only when the data is got, I can do it. Then next thing is, I need to continuously do the training for different networking conditions. So that is also a channel because the network should be exposed to different type of networking scenarios. Which network is artificial network has to be, or neural network or your machine learning model has to be exposed to different type of 5G networking scenarios and models. So it has to learn under different scenarios, even under outlier conditions, it should know how to manage the scenario. Only then we can completely rely on them. For that, we need the data. And it has to be completely updated also. That is another thing. Third one is, now 5G systems do not support, at the node level at least, do not support all the machine intelligence. Now, if you attempt to introduce that, we don't have a compatibility. You cannot seamlessly integrate the existing systems with the concept of ML now. Suddenly, you cannot bring in ML here because they are totally unaware of intelligence. So existing network cannot be used for incorporating this. That is one of the biggest drawback. All of a sudden, we cannot throw the existing network and introduce a new network. That is not possible because huge money has gone into it. So already the existing network will be there, and slowly it gets converted to become intelligent. That is a kind of compatibility we always look for. So that is another problem. Then we need optimized ML model. So far I am telling only about the data. It is not only the accurate and the vast amount of data that is needed, we also need good ML models suitable for this. Usually, the reason for why I've put this point is because ML models means they are good for classification, they are good for all natural language processing, image classification, even for image biomedical image segmentation. For all these things, we are using it. And still applying or using a suitable model for a 5G or a 6G scenario, no? So that has not been explored. Still, it is only in the research level. So we need to explore more and find out optimal models, because the constraints which the 5G and 6G is imposing is very, very stringent. Because we have a very strong stringent conditions on the latency, we expect a particular throughput. All these are standard values. How do I meet out all these values? That becomes very, very difficult. Then we have something called as data privacy and security. And this becomes a problem when there is a huge sensitive information, because all the nodes, end nodes are going to send sensitive information. In spite of all these things, how the privacy and security can be enabled. So these are some of the points. And another interesting point here is there is a resource constraint here. Edge devices often have very less computational storage as well as power. So you cannot run a powerful algorithm in the nodes. So implementation of edge AI is not an easy task, and it requires a lot of work to minimize, make the algorithm lightweight, and all those things have to be carried forward such that this AI algorithm is more suitable to the, according to the capability of the node. We have to define it. So that is, and we are not going to use a same type of node everywhere. It's going to be different. So depending upon the capabilities, the network model also have to change. So all these things are some of the important limitations. And at different, as I've told you, at different stages, network levels, say we need to train the mobile devices, we need to train the base stations, and apart from that, in the management layers also we have to introduce all the changes. So for all this, we need huge amount of data, or in one word I can say, we need lot of techniques. First of all, we need lot of techniques to derive the big data that is needed, because ML is actually data hungry system. So we need to satisfy that. All sources of data we need to collect and work on that. So this itself is another problem. So with all this, I told you what are the requirements of 5G, 6G, and to meet out that, what is the role which ML can play, that we have seen. And to implement ML successfully in the existing setup, what are all the challenges? So only when all these challenges are met out, then we can successfully have an intelligent 5G or a 6G network. So finally, I would like to conclude that machine learning will be an indispensable component for all future networks. It's not only for 5G and 6G. It is also going to be a perennial component for all the future networks. Beyond 6G also, it is going to be helpful. You can use it for network optimization. You can use them for network resource management. For security, you can do it. You can do predictive maintenance. This is something really interesting. You can predict what type of hardware failures and software failures will happen. So the machine on its own will do a simulation kind of thing, and it will try to do all these predictions well in before they occur. So we can actually reduce the downtime of the networks, minimize the downtime of the network. All these things are possible. And apart from this, we can provide an enhanced user experience. And we will really have the experience that we are using a 6G network with all these components embedded, particularly ML embedded into the communication network. So the rise of 6G will be like this. So this will be my concluding slide. So far, the role of our AI was not it was not present in 3G, 4G, or 5G. And only in the later stage of 5G, we started realizing that ML can be integrated into it, because we started getting huge amount of data which is required for meeting out the ML thing requirement. And in 6G, we will definitely have a setup like this. So the base station will have a machine learning module, and the data will be sent to it. Whatever the base station is collecting, it is going to send here, and that is going to be processed. And whatever it processes, the results are going to be fed to an AI model or an expert system, which is going to behave in a very smart manner. It is going to give a reward, or it is going to give a penalty. It is going to give a feedback to the machine learning model. And this machine learning model is going to adjust after the input from the feedback from the AI model. And that is going to be the knowledge, and that knowledge is going to be imparted onto the base station. So we can see that the intelligence of the base station will grow day by day, and it will become very, very strong. It will gain more amount of wisdom. The knowledge will get converted into wisdom, and it will take all the actions appropriately, including resource management, mobility management, all type of network slicing. Everything can be done perfectly by all the modules present in the network. And thank you. We are in the stage of just moving from 5G to 6G. So we are in the midway. And thank you for your patient listening, first of all. And any queries you can ask me.
Madam, in the chat box, Koteshwari Madam is asked, what are the softwares available to implement AI in 6G? Madam, what are the software available to implement AI in 6G, ma'am?
Yes, ma'am. We have a lot of simulation software. 6G simulation tools are there. And MATLAB is giving a lot of support. Simulink, we have a lot of tools, 5G tools available. 6G tools have not come in it. And some of the researchers are using their own emulators for doing the simulation process. For 5G, we have enough simulators. Starting from even with MATLAB, 2023A version has got a lot of tools available.
Ma'am, good evening. Really a wonderful session. It is so informative. Two questions, ma'am. One is that actually when people have been started working on this machine learning process or AI interface with wireless communication, the
Okay.
data sets actually, whether any samples we can get so that the students can or the researchers can apply on to the software so that they can get a simulation outcome.
Yes, sir. There are data sets right now. Maybe I can share the link where the data sets are available. I have actually preserved it. I thought of putting it, but now I don't actually have the link with me. But there are data sets, but the data set is very much limited. They can be used, and it is open data set only. It can be used by any of the researcher. That is there.
Yeah, if you have been able
That
to
link
share,
I will share, sir. I will share that link with madam, and probably she will be sharing that with you.
Fine. Thank you, ma'am. And one more thing is that now, if people have been started to work on this particular area, always for machine learning, people say that a huge amount of data set has been required, and the machine specification for running such a simulation is also need to have higher end configurations. Or
Yeah,
else we
that's
must.
why we have GPUs now. Recently, we have a lot of GPUs, and even cloud services we can be used. We can, if we don't have a GPU, even we can use the cloud services for using that. Okay.
Fine, ma'am. Thank you very much. Really wonderful session. Thank you for making so informative on this particular day. Thank you, ma'am. And thank you, the coordinators, for selecting such a beautiful session expert. Thank you, ma'am.
Thank you, sir.
Thank you so much, sir.
Any participant, dear participant, any other queries? Please.
Ma'am, I
Madam
am
is waiting.
Yes, ma'am.
Yes, madam.
Ma'am, I'm doing my research on wearable devices, ma'am.
Okay, ma'am.
Recently, I have attended for one workshop. They have introduced like wearable devices connectivity with AI, ma'am.
Okay.
That is body area networks, ma'am. I am working
Yeah,
on
yeah,
that.
body area network. We have a sync node. All the sensors will communicate to that. And
Yes,
from the sync node, it can be communicated with any of the cloud server. And from
Okay.
there, maybe it can be connected to a hospital. If there is a alert that comes from any of the sensors, when the
Yeah.
threshold limits are exceeding, then immediately
Yes.
the doctor can interfere and he can look into the parameters and immediately the action can be taken up.
Yeah, ma'am. Ma'am, in the parameters point of view, what are the design constraints we are going to obtain more effectively with the AI, ma'am, with respect to wearable devices?
Actually, the point that is needed here is you want me to tell how much quantity of data is needed, ma'am?
Yes, ma'am. To
Okay.
improve the performance of antenna.
That's what I'm telling. More and more the data. See, if we want better output, there are two ways by which the improvisation can be achieved with ML. One is either the algorithm should be very good. It should be an optimal algorithm. Or instead of targeting, improving the algorithm, you can go for increasing the data samples. Just having more number of data samples alone is not okay. You must ensure that the data sample what you're feeding to the network is a high quality or an accurate value. There should not be any error in that. If an error gets entered into the network, then it can corrupt the process and it can pull down the accuracy. So your false positives will become more then. That becomes a problem. So always whenever, as far as at least for medical data is concerned, because that's more serious thing. So medical data is concerned, before we feed that to the AI model, we do something called as data management. That data management, we do data cleaning. And we try to remove all the missing variables. Missing data values also will be removed. So only a clean annotated data will only be fed to the network. And most of the data sets, if you observe carefully, you can see that the data will be mentioned as annotated data, which is a high quality, correct, accurate data.
Yes, ma'am.
Because any error, any more amount of error that gets added up in the data sample, that will corrupt the performance of the system, and it will bring down the accuracy very low. That should not happen.
Yes, ma'am. Thank you, ma'am. Thank you so much.
Good evening, madam.
Yes, ma'am.
My research is in channel estimation.
Okay.
So if I want to use a deep learning model or a machine learning model,
Okay.
the output for the channel estimation is the estimated channel coefficients.
Yes. Channel coefficients. You need to estimate.
The
Yes.
output of the model, but what we have to give as an input while training?
Yes, madam. That is what I'm trying to say. For different, first we need to, for doing channel estimation, channel modeling is important.
Okay.
So channel modeling, we don't have realistic data sets. Most of them, they do some whatever is available. They are doing it. We don't have realistic data set for channel modeling. Only when channel modeling is perfectly done, channel estimation can be done, because channel modeling is a prerequisite for channel estimation. Fine. So I can tell you my answer in a very simple words. Actually, involving machine learning in communication networks has not been explored more, because we don't really have the correct set of data needed to train it. It is there in other areas. If you take biomedical, in the segmentation, region of interest extraction, all the tumor characterization, intratumoral characteristics, everything you can do with a lot of papers are there, and we have standard models also available. So people have been using machine learning and deep learning algorithms more on specific fields, but it is very much less used in 5G and 6G communication. That is why there is a separate forum, AI for Good. You can refer to this forum, and this forum is focusing on improvising the usage of machine learning and deep learning algorithms for communication purpose. They are promoting this because it is totally an unexplored. Honestly telling, it's an unexplored area. These are all the assumptions. People are assuming that if this is employed, this can be made better. And as researchers, like you, only have to take up this to the next level. We really don't have enough data, or I would say whatever available as the data, particularly for channel estimation, we don't have the realistic data available. That's a most important point which I want to emphasize here. Maybe another 5 years, by 2030, they're expecting, there is a review paper also in which they told this. The data sets are not sufficiently available for the researchers to work, and therefore there is a need. An editorial message is given in a special issue. I don't remember that issue where I've read that. So that editor has mentioned this point itself, and he's trying to promote, let more researchers work for AI for 5G or 6G, something like that. So the data can be collected, more data will be available, and that can be kept as an open source data set, and that can be used by many researchers across the globe.
Madam, if we use the existing channel model, which is already there, for example, a millimeter channel model, if we use, and in general, use the general algorithms, we will be transmitting some pilots through this channel model, and we will take the output Y, and we'll try to estimate H from this Y.
Yes.
In this way, we will be doing in general using some algorithm.
Yes, definitely.
But if you want to do the same thing in machine learning, I am not able to determine what should be the input to it and what should to get the estimated output, channel coefficients.
Madam, basically the concept is this. These are all the channel coefficients. Like, for example, you have a matrix for the channel will be represented with the matrix, and every entry in that matrix will be a channel coefficient.
Yes.
You take a row from first antenna. It's basically from a MIMO, right? So first antenna at the transmitter end, the other antenna will be at the receiver. 1-to-1, if the communication is going to happen, all the metrics will be given as an input. So all the channel coefficients will be fed as the input to the ML model. And if these are the coefficients, the expected quality SINR value is this much. Like that, it will give a ranking for the SINR value. So next time, when the same set of channel coefficients are going to be given as the input, as an unknown data to the network, it will remember the past pattern and it will say this will be the possible SINR value. Therefore, the command to increase or decrease the transmit power will be accordingly altered by the transmitter. So the transmitter will be generally how the process happens. You transmit something and the receiver will receive. SINR value is actually what is the value? Say it is X dBs, we are finding it. For that X dBs, from that we estimate whether the channel is good or bad. Accordingly, the transmitted power will be increased so that the target SINR value is met. This is how we work. So everything will be done in one go by an ML, because initially you have trained your model for this channel coefficient. This is SINR. If the target is this, to what level the power has to be increased, that also will be fed to the network. So it will increase automatically by that level. Without any delay, it is going to do that. So different, if you have a, say, for example, an array with 100 antennas, your matrix size is going to be having 100 rows and say 100 columns. 100 cross 100 is the size. So for every 1-to-1, 1-to-2, 1-to-3, like that, you are going to get the channel coefficients, and that is going to be trained. And it is going to remember all the values. So if this is a channel condition, immediately it will give the command to the transmitter, increase the power by this. That's all.
Okay, madam.
So
Thank you.
I'm telling it as a very simple process. That data, collection of the data is very, very difficult.
We can generate the data by considering some
Yes,
channel.
we can generate, but how far your output is going to match with a realistic one, that is going to be a big problem. We can complete our work. Research can be completed with that.
Simulation, by simulations we will be able to.
Yes, exactly. But
we don't know whether it works for real data or not.
That is where is a problem though.
Thank you very much, madam.
Okay, ma'am.
Participant, any other question?
Ma'am, as you use the term like fuzzy logic, you didn't use like fuzzy logic, sorry, fuzzy terms. Can we trap the signal within a particular area using this fuzzy membership function, ma'am? In your
Madam, fuzzy is a concept which will be used when the decision is hazy. If there is a haziness or ambiguity in making a decision, fuzzy systems will come into the picture. Along with the neural network, which is an AI model, you can combine fuzzy also. Fuzzy neural model combination is existing. So wherever AI cannot make decision, fuzzy will enable AI to take an appropriate decision. So fuzzy membership function, you can have triangular function. Any type of membership function can be activated to get the output.
okay, ma'am.
Hello?
Yes, ma'am.
Dear participant? Any other questions? Okay, madam. Dr. Jayanti, madam, thank you so much, madam. Your lecture is so informative, too interesting and informative. Your expertise will help us understand the following areas such as ML and DL, Edge AI, ML in wireless system design, ML and AI embedded and channel estimation layer, and integrating network infrastructure, the implementation of channels, and so on. It's very informative, madam. This is very useful for especially for researchers. Thank you so much, madam. It's very interesting.
Thank you, ma'am.
madam.
Thank you for your kind words of appreciation.
Thank you,
So I once again thank the coordinators for having given this wonderful opportunity to share my expertise with you. Actually, I have applied artificial intelligence for intelligent transportation system. I have a separate set of publications on that, and I have also done it with medical images. I have also done with maybe I just thought whether I can share that, because my time limit was very less. So I thought only when the introduction is given, it will get over. So how AI can be applied for predicting the traffic in a city. Actually, I have taken the Pondicherry city, my own city here. What is the traffic that is existing? We have taken a junction, Indira Gandhi Junction, where the density of the traffic is going to be heavy. That particular area has been taken for our study, and we have done a prediction. We have developed an app also. It's an AI-based app. So someone who is entering into to Pondicherry, the moment when they turn on this app, what they can do is they'll be able to check whether there will be a congestion in the road, what they are going to take up. Though Google is doing the task, Google is for at the global level. It will not know the nook and corners of Pondicherry city. So there are lots of small roads which are available. So the concept, what I did was, from a point A to point B. Point B is the destination, and point A is a place where the vehicle is currently present, current location. If I find anywhere in between there is a congestion, then the app will be suggesting a lot of alternate paths. And that alternate path can be taken up so that the congestion can be completely avoided. All this is with the help of AI. We have developed a small database and the system is working. Not only this, suppose tomorrow I want to go out. Today I can plan what will be the traffic in that particular road. If I enable that, if I activate that app, I'll be able to see at what time the traffic will be less in that particular road so that I can smoothly go and come. So those type of predictions also can be done. And with the realistic data, actually, I really had some people were asking, how did you get the realistic data? Purnima ma'am, I think you are asking about channel estimation, isn't it, ma'am? You are asking the question on channel estimation.
Purnima madam only.
Yes, I will tell you, ma'am, I was hunting for this data. So what I did is, I went to the traffic police SSP. I just asked him, can I get the data? He said, no, madam, please use your students, get the data and give it to me. Like that, he started putting. Okay, no way. Then I was just thinking what I can do. And what I did was, I started asking, I went and asked him for the CCTV images, footages. That is also not existing in most of the junction places in Pondicherry, because they had a network, but it was like taken away by people, and it was broken, not working, so many issues. Then what I asked them was that SSP had helped me, like nearby shops were there, which were focusing their cameras towards the road. No? So I got those footages, CCTV footages, and that continuous video recordings, I've just converted into images, got the count with the help of a suitable algorithm. We have used actually YOLO algorithm to find out the type of the vehicle. So we had 3 different types of vehicles. 2-wheelers we segregated, 3-wheelers and light motor 4-wheelers, heavy trucks, heavy lorry and other things. So 5 different categories. Number of vehicles under each of these 5 categories, that also we found. And that was used for training. And when we started testing, finally we got the result. And that result, when we matched, we made a person to stand on a day and find out really 93% accuracy we were able to get. So what I'm trying to convey here is, all of us need data to work. Nobody is providing data, at least in our country, we are not getting it. So what we can do, I just thought like that, and I landed with, I myself will get the data. You give me the CCTV footages. If we go and ask, the shopkeeper will not give. So we need some power to be applied to get it. So I've got for 3 months continuously. And that 3 months data I've collected. And from that, I was able to work. So we did like this. For 10 days, when you give the data, the next 2 days, how the traffic will be, it will be able to predict that. Not only for 2 days, it can also predict for 3 months. From now, 3 months, maybe today is the 10th of Jan. So April 10th, what will be the traffic? That also I'll be able to send from this. But that time, the accuracy will be little less. What I did was, just traffic alone will not be okay. So other parameters I started thinking of. What is the climate condition? If it is heavily raining, people will not go. So let me take that. And if it is some auspicious day, there is a lot of functions which is there happening, means most of the people will go out because they have to go and attend the functions. Near Kalyana Mandapams, local event, something is happening, a lot of people will go there. So I started collecting all those data, give it to my network. Tremendously, the accuracy has got improved to 93%. Astonishingly, it is happening. With traffic data, we were able to get only around 78 to 79%. The problem why it is 79% is because those CCTV cameras were not completely giving the complete coverage of the entire road. If it is on the center of the road, we will get the complete thing. This was from the corner. So some vehicles which were moving 1 or 2 on the corners were actually dropped out. So I added this over and above that with the climatic conditions, because now we have weather forecasting apps which are available. April 10th, what will be the climate? I can predict that. That also will be used as the input to the AI model. Everything is added and now the accuracy has gone. So it is all the efforts what we are putting. That's it. So let's think differently and try to get the data. We have to get the data. And to Purnima ma'am, I just wanted to tell you, all the best for the work
Thank
that
you,
you have
madam.
done now. And only thing is, my humble request is you do the work and you publish the data. Make it as an open data source so that others can follow that and use it. I'm actually
madam.
working hard to do that. Yes, ma'am.
You inspired me, madam, now with your idea. The way you thought to include the
Yeah,
feature.
That's what I wanted to do it. Somehow
Madam
I have
got
to complete
achieved also. Getting there, you got achieved.
Okay.
Thank you,
Yes,
madam.
ma'am.
Thank you.
Thank you
you
so
for
much.
your hard working, madam.
I've taken so much of your time, but I don't know.
No,
Sorry
no,
if
no,
I
no, no problem, madam. It is very interesting. You are informative, madam. How to take the data
I think
is also one
experiences
of
can
the.
be shared in a separate
Yes,
session.
yes. Getting data is also a very big task.
Yes, that's what I'm telling.
Yeah, this is the one of the way we got the ITI. So.
Okay.
We will implement, madam, from today onwards, at least. Thank you, madam. Thank you so much, madam. You are spending a lot of time in that too. Now 9:40. Thank you, madam.
Okay.
Thank you
The
so
biggest challenge was the earlier speaker has taken too much of my time. He has taken up to 8. So I was a
madam,
little worried whether I'll be able to do
He's
it.
an international speaker. He got some disturbance in the next,
Okay.
madam.
Thank
He
you,
could
ma'am.
not able to. Thank you so much, madam.
Okay. Thank you
Good
so
night,
much.
madam. Good night, madam. Dear
Shall I leave the
participants-
call, ma'am?
Yes, madam. Yes, madam. You can.
Thank you.
Madam, please share your PPTs, madam.
I've already shared, ma'am.
Okay.
I've
Madam,
already
your
shared
contact detail also, madam.
my contact details. Now I will type now. I will type here itself. 1 second. My thing is Jayanti at p2univ.edu.in. This is my mail ID. And my WhatsApp number is 94436171183 /9150302112.
Thank you very much, madam.
Yes. Okay, thank you then.
Okay. Thank you, ma'am.
All the best for all the researchers who are taking up this work. Okay, fine. Thank you so much. Thank you for listening. And that's so nice. Yes, ma'am.
Feedback link, ma'am.
Oh, I will send. Already I send, no, madam. Okay, I will send again. No
Okay.
problem.
Shall I leave the?
Ma'am, can you please repeat
Okay,
your
madam. You
phone
can
number,
leave,
ma'am?
madam, now.
Thank you.
Madam, dear participant, tomorrow we have section at 2 o'clock. The section will start at 2 o'clock. We have 3 sections, no? 2 to 3, 3:30 and 3:30 to 3 sections. So tomorrow we will meet at 2 o'clock. And also one more, after completion of the 3 sections, we have test session also there. I will share I will share the test questions. You have to score minimum 75 marks to get the certificate. Okay, dear participant, you can leave now. Yeah, sure, madam.
Shall I stop the recording, ma'am?
Yes. Yes, sir. Anup, sir. Yes.
Okay, ma'am.